Okay, so I'm making this video for extra credit for Mr. Pacanova. I'm explaining the proof on page 404 for cos of u plus or minus v equals cos of u plus or minus sine of u sine of v. If you're like me, you've found that reading this basically does nothing. So I did some research, some help from friends, and now I know how to explain it better. So here you go. So I basically just transferred what the diagram in the book to paper right here, so I can explain better like the logic behind it. So right here is angle V. It's also arc AB with B being the coordinates x of 1 and y of 1. Right here is angle U minus V. It's all of this, and it can be represented by the arc AC with C being the coordinates x of 2, y of 2, x2, y2, not actually that, just a 2 right there. And all of this right here is angle U, which can be represented as arc AD, with the coordinates of D being x of 3, y of 3. So based upon this, we know that actually arc BD is equal to arc AC, because arc AC is equal to U minus V and we know that all of this entire angle right here is U, and right here is V. So it would make sense that arc DB would be equal to angle U minus V, because this angle U with the exception of V. So it's angle U minus V. So also arc DB is equal to U minus V. So arc AC is equal to DB, which would also mean that since the arcs are equal lengths, these line segments connecting B and D are equal to those connecting C and A. So now I'm going to use this information to prove the trigonomic identity. Okay, so I've labeled line DB as G and line CA as H. So now those two equal G and H. So another way to write line segment G would be able to use the Pythagorean theorem. Right here is a right triangle with G being the hypotenuse. And we know that for a right triangle you can use the Pythagorean theory. So G could be represented, as these are two sides, as the square root of E squared plus F squared. But how would we write E and F using x coordinates? Well, if we look at it this way, we could write it as x3 minus x of 1, because it would be x of 3 right here. What is that? That's like a negative something, minus x of 1 right here. And if you put them together, it would be equal to the length of E, just in negative terms, but it doesn't really matter if it's negative or positive. So x3 minus x1, let me write that here, x3 minus x1 equals E. Now, to find F, you do y of 3 minus y of 1. So y of 3 would be right here, that's a negative, minus y of 1, which would be right here. And if you really wanted to write it out, it would actually be something like this, but this length right here would be exactly equal to the length of F. So y3 minus y1 equals F. Alright, so since G is equal to the square root of E squared minus F squared, it would also mean that G is equal to the square root of x3 minus x of 1 squared plus y3 minus y1 squared, because these equal E and F. Now we can use a similar method to find out what H could be equal to. If we draw a right triangle right here, H would be equal to, let's label this I and J. H would be equal to square root of J squared plus I squared, using the Pythagorean theorem. So how can you write j in terms of x squared and x and y? Well, if you look here, with this being c, j is actually equal to the length of, it's equal to the y coordinate of c. So j, you can also write it as j equals y2 minus 0. I, if remember, a is 1 right here. Sorry, I forgot to write that out. A is 1. So I is equal to the x coordinate, the length right here, plus the length right here. We know that the length right here is 1, and we know that the length right here is x2. But we have to put it, since this x2 is negative, we can also write it as, x2 minus 1. Because x2 minus 1, it would extend out here, and that would be actually the same exact length as I. So then we can write it out as line h equals the square root of y2 minus 0 squared plus x2 minus 1 squared. So now we have our equation to prove cos of v plus or minus v equals cos of v plus or minus sine of v. It's right here, with this being g and that being h. So to simplify it further, we can just square both sides. So we end up with x2 minus x1 squared plus y3 minus, x3 minus x1 squared plus y3 minus y1 squared is equal to y of 2 minus 0 plus x2 minus 1, and both of them squared. Okay, so now we can expand this. Say x of 3 minus x of 1 would be equal to x of 3 minus x of 1 times x of 3 minus x of 1 plus y of 3 minus y of 1 times y of 3 minus y of 1 equals x of 2 minus 0 times, y of 2 minus 0 times y of 2 minus 0 plus x of 2 minus 1 times x of 2 minus 1. Oh, sorry, you didn't see that, but here it is. So now we need to simplify this, or rather multiply it. So x of 3 times x of 3 would be equal to x squared of 3. Alright, you don't even have to see me simplify. So I went ahead and multiplied everything, but now let's simplify this even further. So we can write this as x2 of 3 plus x squared of 3 plus x squared of 1 minus 2x1 x3 plus y squared of 3 plus y squared of 1 minus 2y1 y3 equals y squared of 2 plus x squared of 2 minus 2x2 plus 1. Sorry, I didn't write that. And now we can simplify this even further, because we know that x squared plus y squared equals 1. So, in the unit circle. So, x3 squared plus y3 squared would equal to 1. And plus x squared of 1 times y squared of 1 equals another 1. And then minus 2x of 1, x of 3, minus 2y of 1, y of 3 equals, and then x squared of 2 plus x squared of 2 equals 1 plus 1 minus 2x of 2. Simplify that even further. 2 minus 2x of 1, x of 3 minus 2, y of 1, y of 3 equals 2 minus 2x of 2. And so now you can get another piece of paper. And if we subtract 2 from both sides, it's minus 2x of 1, x of 3 minus 2, y of 1, y of 3 equals minus 2x of 2. And if we divide this by negative 2, we get x of 1, x of 3 plus y of 1, y of 3 equals x of 2. So now if we were to remember the diagram, we could basically substitute this for cosine of u, because no, cosine x of 1 would be b, so which is v. Cosine of v times cosine of u plus y sine of v and sine of u equals, and x2 would be equal to cos of u minus v. So there, I've proved the proof of the trigonomic identity of cos of v times cos of u plus sine of v times sine of u equals cos of u minus v.